Hello, one more video today. In this video, I want to talk about a little bit of graph theory and what's called the friendship paradox. So let's jump right to it. Okay, so let me hit you with a fact. All right, so if you add up the number of friends that each account in Facebook has for every single possible uh, Facebook account that exists right now, then the total number of friends that's added up together is going to be an even number. Can you think of a reason why that must be true? So obviously I didn't actually count, or you seem like it's impossible to compute because by the time you're done counting, the number has changed already. But let's say we could freeze the database and you can add up all the number of friends. It should be even, and I can say that very confidently. Can you come up with a reason why that would have to be true? Well, it would have to be true because each friendship is counted twice. So, for example, if you and I were Facebook friends, uh, every time I count you as a friend, like you also count me as a friend. So each friendship bond between any two Facebook page is going to be counted twice. So of course, the sum of the number of friendships times 2 is going to be an even number, right? I hope that made sense. You could do this if we weren't social distancing or distance learning. You could do this magic trick. So what you do is in a classroom, have people give each other handshakes and count the number of handshakes that each person has made. At the end, have each of the person report the number of handshakes that they've done. Some people have shook hands even number of times. Others have shook hands odd number of times, but the total sum, if they remember correctly and report honestly, then it should be even at the end. I used to do this to introduce the idea of this graph theory, but you shouldn't be shaking hands nowadays. Okay, so what are graphs? So graphs are dots and lines connecting them. So the dots are called vertices, and connections between vertices are called edges. And so if you're thinking about Facebook situation, each vertex is like a Facebook page, and each friendship connection between the accounts is going to be edges. And it's just kind of graphical, abstract way of drawing the situation. So below, there's 6 examples of graphs, and I want you to kind of count the number of vertices on each and edges, and see if any of these are similar. So I encourage you to pause the video and do that for each of the graphs. And I don't know if you noticed or not, but the first 3 pictures, these 3 graphs, are actually exactly the same graphs. So what I mean by that, they all have 4 dots, and they each have 3 edges coming out of it. And they're actually, the relationships are exactly the same. So if you look at this picture right here, and imagine this edge, you kind of lift that off the paper of the screen, and then pull it to that direction, then you get this picture. So the connections are the same. It's drawn differently, but it connects the same two vertices. So it's actually the same graph, even though it's kind of drawn in a weird way. So now, if you take this vertex right there and kind of move it towards the middle, then you'll get this picture. So you did that without breaking or making new connections. So all three of these are actually the exact same graph. So the way it's drawn, where the vertices are placed or how the edges are kind of bending doesn't really change the quality of these connected vertices. So you don't worry too much about how it's actually drawn on paper. You just kind of draw it the way that's easier to understand. I hope that makes sense. Okay, but there are some quality that you can care about in graph theory. So one thing that you might care about is what's called incidence number. So incidence number is number of edges that coming out of a particular vertex. So incidence number for all four of the vertices on the first three pictures was 3. Each vertex had 3 edges that's coming out of it. Another quality that you might care about a graph is the notion of what's called the distance. So distance between two different vertices is the shortest number of edges you need to cross to get to the other edge. So for example, if you're looking at the distance between these two vertices, the distance is 1 because you just hop over that edge and you can get to the other one. There's another path to get there that takes 3 edges, but you only count the shortest one if you're talking about a distance. If you're looking at distance between those two vertices, then the distance is 2, no matter which way you go. So the smallest distance is 2. So that's what you would report in that example. Okay, so those two definitions I want you to get used to. So there's a couple questions asking about that. Okay, so there are a lot of things you can do with graph theory. So obviously, like social networking is something where these types of graph idea is used. It's also used in epidemiology and looking at how diseases spread. So like in recent times, there's this COVID-19 that's going around. People study different types of social networking, not so much online, but if you go to school or if you go to work or if you go over to friends' parties, like then you make a connection, physical contact with everyone that gets close to you. And this disease only spreads through these physical contacts, or at least get close. So this is a situation where what's the opportunity? So each time you make you close to someone, you transmit the disease with a certain percentage chance, and how much opportunities it has to go over to the next person, and then that person contacts somebody else, and how the disease spread on and on is something that's heavily studied. And in fact, this whole stay home order and social distancing, this is exactly the advice, effective advice that they found in a way that kind of stops, or not stops, but maybe slows the rate of transmission. So one surprising fact that people have found that even if you look at bigger and bigger graphs, sometimes the distance doesn't grow as fast as you might expect, even if it's huge. You might have heard the phrase 6 degrees of separation. This is an idea that, so there's billions of people who live on Earth, and each person has a certain number of contacts, like close people that you can call friends or acquaintance or family. And it turns out that like you could pretty much get to anyone if you go through 6 different relationships, starting from anyone. And one example of a game that's based on this idea is what's called the Kevin Bacon game. So if you like movies, maybe you have played this game already. Let me show you what this game is like. Let's see if I can go over to this screen. Okay. All right, so this is a website that plays the Kevin Bacon game for you. But basically the idea is you think of an actor. So maybe I'm thinking of Jackie Chan. And the game is to connect each actor to another actor through a movie that they were in together, up until you get to Kevin Bacon. So Jackie Chan was in Final Cut with Johnny Depp, and Johnny Depp was in Black Mass with Kevin Bacon. So there's only 2 relationships, right? The edges are the movies, and vertices are the actors. So that wasn't a very good one because it was small. So maybe I could come up with an actor. Let's see, what if I came up with an actor that was kind of old? So maybe like Charlie Chaplin. So, oh, it's still only 3. So there's only 3 movies that connects to Kevin Bacon. So I don't know too many actors or actresses. So maybe you can come up with obscure, like think small actors, but did appear in like a actual movie that would be in the database, and see if you can get higher number than just 3. Yeah. Anyways, that's the idea of 6 degrees of separation. I've never seen anybody get Bacon number of 6 before. See if you can actually find one. Okay, let's get to the main paradox of the worksheet. So the paradox is called the friendship paradox. So this is something that appears in graph theory naturally, and it sounds very paradoxical when you first hear it. So what's the friendship paradox? So a typical person have less friends than average number of their friends. So for example, if you're looking at like a Facebook account, I don't know what's a reasonable number of friends to have. Maybe let's say 100 friends. Maybe you have 100 friends on your Facebook page, and this is a lot of work. So don't actually do it, but go to each of those friends' page and count the number of their friends, and look at the average of all your friends' number of friends. Then on average, your friends have more friends than you, which kind of sounds depressing, but it's actually, this is the way things are, and there's a reason for it, and I want to see if you would be able to figure it out. So this is like a fake Facebook account situation with very few number of friends, so it's reasonable to compute. What I want you to do is look at each of these person's Facebook page, count the number of friends, and compare that against the average of their friends. So I'll just do one, so it's easier see what I want you to do. So let's say I'm looking at Emily. So Emily has 3 friends. So each of the friends is Sarah, Ashley, and Joshua. Sarah has 3 friends as well. Joshua also has 3 friends, but Ashley has 4 friends. So 3 plus 3 plus 4 is exactly 10. That's out of 3 friends. So the average number of friends is 10 over 3, or 4.33 repeating. Sorry, 3.33 repeating, which is 1/3 more than the actual number of friends you have. This isn't always true. So of course, the person with most friends, like Christopher, is going to have more friends than the average of their friends. But typically, if you pick like a random point, turns out that they're below average when they look at it. So I want you to try to explain why this would hold. And after computing this a few times, I think you'll get to see the pattern of the reason why things like that tends to happen. So if you ever feel like your friends have more friends than you, or if you're feeling discouraged by that fact, um, there is a reason for it. So it's actually true for most people. So maybe that makes you feel better, or maybe not. I don't know. But that's what the friendship paradox is about. Okay, so that's it for this worksheet. I'll see you next week with more statistics and data driven paradoxes. All right, see you then.